So today, first of all, this isn't really going to be a talk. This is going to be me explaining a cool mechanic in games and like open discussion. No real agenda. If you have a question, say something. If you have a comment, say something. You know, we're not on a real timeline, just as long as I get done before everybody's slamming the door, right? Okay, so we're going to talk about various ways to handle shooting in games, right? But before we do, let's just do a real quick why. So in game engines in general, especially in Unity, you have what's called a collider. And the idea behind this, programming-wise, is let's say I have a circle or sphere, right? And I want to know when that sphere runs into another sphere. Simple calculation. Is this radius inside this radius? If so, we have a collision, pushback, or whatever you got to do, physics engine, right? I'm going to demonstrate that real quick with some blocks falling. Each one of these has a collider on it, falls, impacts, does this, right? Pretty simple. But if you think about this from a programming aspect, every one of those colliders at every frame of the game has to say, am I in this collider? And it does that for every single one of them. Quite expensive. Now, Unity does some tricks where what's called the AABB axis trick, which it basically calculates a square around your object, and it says, is that anywhere close to this one? Because if it isn't, I'm not even going to attempt to calculate it, right? And if it is, well, then now we start doing calculations. So that saves on optimized stuff a little bit. But still fairly expensive, especially when you're talking about games, 60 frames per second, right? Like, that's very fast. What's up?
So what you're saying right now is those blocks, it's checking right now to make sure it's touching the ground.
Not just the ground, but each one of the other ones. That's why when they fall and they hit other blocks, they'll bounce off and move around and so on and so forth. You can actually see this, if you like, right here. We'll turn the change this over to a wireframe, and you'll see this. You can see each one of the wireframes on this. So every one of these, at every frame, again, 60, well, hold on. Sorry, I have it on maximum. Uno momento. All right, cool. You'll see this as these fall. Every frame, 60 seconds per frame, per second, 60 frames per second, right? It's saying, is this calculation, that's very expensive, especially, that's only, I don't know, maybe 100 colliders. Your games, you're going to have, up thousands of objects and whatever, so it gets very expensive very quickly, right? Now, again, it uses some optimization techniques to where, for most things, building cars, so on and so forth, not a big deal, throw a box collider on it. I will say, and this is something to take note of in game dev, is each one of these is a box collider. Any primitive, right? A capsule, right? Very easy to calculate, very quick. Now when you get into meshes, so if you have a box, in fact, even on these, each one of those has a face. The face is the outside of that, right? If you do a mesh, if anybody knows anything about GPU calculations, just floating point triangles, right? Two triangles make a square. That's why if you ever see anything game related, it might look sort of boxy and triangle-y, right? That's all those are polys. It's your high poly count. Well, when you do a collider, a mesh collider, every single face from that triangle, you might have thousands, it has to calculate. And that gets really expensive. When you rotate items, every one of those has to be calculated. Very expensive, right? Doesn't mean you shouldn't use them, just understand the underlying, not just, hey, if I want something to collide, I can throw a collider on it. Doesn't matter what's going on in my game, it's going to work. I'm going to demonstrate. So, we're going to go back over to my scene and take a look at this domain. So very expensive, right? So if I asked most junior game devs, you want bullets to run into stuff, right? I want to shoot a bullet When it hits something, I want an explosion to happen or a sound to happen or whatever, right? You're like, oh, well, I'll just throw a collider on it. When it collides, I'll do that, right? Sounds pretty good. Except, again, going back to the computationally expensive. So, I'm going to demonstrate, yeah, well, we'll get into that. But I'm going to demonstrate the use of a collider on, sorry, this is very small, or a bullet rather, with a collider on it. So this is slow ammo with collider, and you'll be able to see this. I'm going to zoom in here. You'll be able to see this bullet because it's really slow. Hopefully you can see it anyway. So that bullet is going slow, and it hits the wall, and we have a collision, right? Nope, no problem, right? Because that's slow enough, and there's few enough objects on the screen. No problem. We can have that collision works. However, I mean, you can even do quite a few of these if you want. I mean, because again, not a lot is going on, and it's very slow. So you think about that. Every one of those colliders is going, have I hit something? Have I hit something? Have I hit something? That many? No problem. Perfect performance, right? But if you take, that was at a speed of 10, by the way. If you take a fast ammo with a collider, so this is moving at, I think it's 300. You'll notice, now, those bullets are shooting, right? You can see them coming out the backside. No collision. What's happening? Why isn't this registering? My gun doesn't work. What's happening is that they're spawning at their normal spot, but in the time that it takes for the game to run a frame, that bullet's over here. At no point did it say, am I inside this box? Because it's already on the other side. Too fast, right? Oh, well, so what are we going to do? Because we need some kind of collision to happen. In games, you have you have a few different ways, but two main ways to register a shot. You'll notice this. Games like some sniper game, right, where you want super accurate, I want to follow the bullet. If there's wind involved, I need to be and it takes time for that bullet to get to its target, right? That's one approach. The other is like, say, Halo. I see something, I pull the trigger. If that is an enemy or something I can hit, instant hit, right? There's no time for that bullet to travel. I don't need that. If there's something there, it's a register hit. Those are the two primary ways. Is you have a projectile that's moving along at a per frame thing and an instant hit. It's not a between, it's just, hey, there's something there, we register the hit. I'll show you an example of, I call it laser, but same idea. I'm going to show you some code behind this too, by the way. We'll throw the laser in there first just to show you. Now, the thing I would like you to pay attention to is that while this is shooting, eventually, those lasers are registering a hit because that wall is in front of it. If I go eventually this way, so on and so forth, right? So it's sending out a single beam, and if there's something in the way, it goes to that point. If it isn't, it goes beyond it. That's instant, right? There's no time of travel. And then the projectile one, which again, for stuff like sniper, things like that, you want a projectile to go the distance, because maybe it's affected by gravity or wind. I'll give you an example of that. So here we have an ammo that is slow ammo. Slow ammo. All right, so this ammo has what's called a rigid body on it, so it can be pushed by forces like gravity. So right now we have it set to the normal gravity, which is negative 9.81. That's the factor of gravity. And you'll notice that this ammo, when fired, this ammo, when fired, goes down and to the right just a little bit, right? Because we have a factor, if you'll notice over here, it is pushing down on gravity and over to the x. So this would be like, say you want to calculate curvature of the earth. You want a super simulated thing. Or wind. I mean, maybe you're making a field goal kicker, right? You want to calculate. This would be the kind of stuff you want. You don't want an instant hit. You want my projectile to move and then be affected by gravity. So this would be another example of a projectile one that you want to do. But again, even with this, you run into the problem of, okay, I have a projectile moving through for whatever reason. I can't do it with Collider. How do I register something fast? Now we're going to get into the code. So, jump over here. Let me make sure this is big enough. This is the laser ammo. Now, ignore the rest because this is all just show. But this is the thing that is important. Is what I'm doing in this line is I'm sending what's called a Raycast out. So remember the computationally expensive stuff of calculating all this stuff? Raycast is a single line from one point to another point. And if anything registers that, we got a hit. No more calculating size, no more calculating versus everything else going on the scene. One line, here, here, was there anything in between? If we do, we got a hit. Super fast, right? That's the instant hit. That is what you would use if you were doing the Halo one. I got my sight, pulled the trigger, if there's anything there, instant hit. No travel time, no nothing, register. That's why those lasers are immediately there. There's no cost. We switch over to the projectile one, and pull that up. So here is the one to pay attention to on this, which is a Linecast. Very similar idea. The difference is that each frame, what I do is calculate what was the last point of my projectile and what is my projectile at now. So what you're doing is every frame, if there was anything in between these 2 points, if there's a hit, we've got some. Again, immediate calculation, and it doesn't matter if it traveled 1 meter or 500, right? Remember, the reason we run the collider problem is because it traveled too far between the distances. This is just saying, doesn't matter. What was my last position? What is my position now? If there's anything in between that, we have a hit. What's up, Kevin?
How would you change the equation? How would you change this line here if instead of doing a line, you want to do like a curve, like a parabola or something?
You actually still could do that, but you wouldn't calculate the curve, right? So remember, every frame this is being called, and it's going point to point. So remember the one we had moving, like the wind one? What that would actually be doing is going, right? But you're still calculating in between each point. So even though the bullet is swerving, like being affected by force, every point in between there would be checked to see if there was a hit. So a good example is that slow heavy armor or ammo that I did that was going in the bottom.
Yeah.
That is using this function. It's looking to say, hey, have I been here, 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 and then at the corner of that wall, I've got a hit. Now I throw my sprite up there, the little bullet hole, and boom, you've got a hit. You got a slam dunk. And that's the two bases for shooting in most games. Go ahead.
So Raycast shoots one line of sight thing and can tell yes or no if I've hit something. Linecast feels like there's some overhead that comes with it because of the extra calculations.
Not really. The only difference between Raycast and Linecast is Raycast is going to be from a start point in a direction. It's not point to point. So in other words, if you shoot it, it's just saying from this point 500 meters forward or 100 meters, whatever you set it as, this forward, as opposed to a Linecast is point to point.
So you have, you're setting the last check position at where it is.
Correct.
And if you wanted to simulate some left winds or something, you could just increment whatever the right position is each step by a certain amount.
Sort of.
And it would.
You understand that this calculation is it doesn't care where the body it's attached to is. So if your body is curving, the body, your bullet, is going this way, it's going to calculate point as it curves. So it doesn't care. This is abstract. It doesn't care if your bullet is going up, down, backwards,
Yeah.
exploding. It says, last time I checked, I was at this point. This time I checked, I'm at this point. Send a line between those 2 points, and if anything was there, you got a hit. And think about that from a computational, right? We're not checking faces. We're not the normals of anything. We're not checking the size of anything, right? If you wanted think if you're max painting, right, where you can slow down and increase the speed of bullets, right, or the speed of your person and the bullets slow down. Same exact thing. This bullet has a speed of like 100 or 300 or whatever it is, right? Well, if I slow my gain down, the bullet needs to slow down as well, right? So if I have that based on whatever my game is running at, now my bullet, without any change in code, is now moving at that same rate. So you can slow down bullets, have precision, accuracy. If you want, so this is an example of doing one single from the middle of your bullet, your object, to another point, right? But let's say you really, really wanted accuracy, right? Even if you lined your bullet with 5 line casts, right? The outside of your bullet, doing 5 forward to see if any of those hit, even that, exponentially less expensive on your calculations than doing a collider, right? And again, there's no real room for error, right? Because it's point to point. So if any of those 5 hit, it's going to be a hit at that point. So it's very precise. It's just about what you would want in your game. Do you want the Halo type shots where it's instant shot, no effect on anything, or do you actually want some realization, no matter how fast it is? Would be this approach. Obviously, this is doing a check per frame. This is more expensive than the single Raycast, but I mean, so cheap that you really don't have to consider it, right? Like it's not something that you would have an issue with. And honestly, that is the basis for almost this is actually a very old, and that's why I mentioned that this isn't a Unity thing. This is a really old id Software, Doom and stuff, right? Like I think Carmack's actually the one that came up with it. Was just like, hey, we need a way to figure out whether in Doom we've shot somebody without checking all the walls and checking every texture and checking. No, we just send out. It's genius, but this is a very easy implementation in Unity for this, and yeah, it works quite well. I will say, just to go a step further as far as optimization, because really that's the peak of this talk, right? Like that's the approach that you would use one way or the other. You can do. I will say so. I have an effects manager, and I've registered that as a service. So anytime that an impact happens or a fire happens, as opposed to attaching it to any specific bullet, I simply tell the effects manager, hey, this has been hit, or this has been fired, do the appropriate thing, which is like transfer over. You'll notice if, let me get this other bullet back over here. If I'm doing if I'm doing this, the textures, the bullet hole textures, they'll stay on the wall, right? For a minute. But if I like push it over, they stay on the wall as opposed to just simply sticking in the air. Now that takes a little bit of finagling. Like I'll parent the wall object to that and then bring it back. Something else that you'll notice, optimization-wise, is that when I start this, you'll notice these things pop over in the corner. The object pools. So for instance, creating and deleting game objects, quite expensive, right? You can't just dereference it and say, okay, well, garbage collection might get that one day or something. You're going to run out of memory quite quick. Object pooling, I create 100 bullets on start and disable them all, and then as I need them, I just pull it. Same thing with the effects. You'll notice these bullets. Activating and expanding. This is not a game engine thing. You guys will work with object pools in everything that you do. But yeah, so that's kind of the height. Colliders. Anybody have any questions? Colliders, Raycasts. Anybody want to see code? So I'll walk through this whole step. Projectile ammo is derived from ammo, which just gives you some stuff. If anybody knows anything about Unity engine, Unity does not an inheritance model, they do a composition model. So every game object that you attach to an entity will run awake when it pops up when you start the game. Update runs every frame. So what's happening here is it's going every frame of the game. It's calling this has hit, which is a bool, has it hit something, which goes down to has hit, which I showed you before does the Linecast. If there's a hit, right, sets it to result. It is creates the impact data, which is time, where it was facing, what the velocity was, stuff like that. Sets the check, sits out over stuff. If anybody is not familiar with CSharp, the out parameter, if you've got functions, you guys have functions before that return a true or false, right? Which is cool for checking on something, but if you don't want to do it with an out parameter, and you don't, I mean, you could do it with like a tuple or something, but basically, if this is true, it will also spit out a variable with a value. So that's what's happening here is if this comes back as true, it sets impact data, and then you have access to impact data outside of that. So we have a hit, we call, which sends it to the effects manager. Put a bullet up on the wall. Same thing with fire. When fire happens, it calls, does a sound. We're good to go. Any questions? Yeah.
Compositing?
Say what?
You said that it uses compositing instead of...
Right, composite over inheritance. Actually, Unity is an extremely good example of this. So the idea is, let's say, okay. So we have an entity in here called turret, and turret is made up of a whole bunch of components. This is the transforms in here, the turret controller script, the gun script, the rigid body. The cool thing about, this isn't really pertaining to my talk, but it is really good to know. Composition over inheritance. Inheritance, you would be like, you create a base class, and then something inherits from that, and they have all the properties of that one. And you keep going down the line. It gets very complex. As opposed to composition, which is you create something, and then each thing that you attach to it does its own thing. So the cool thing about composition is I could take away this gun script, and everything else would still function perfectly fine. I could take away this rigid body. As long as there wasn't a direct dependency, you guys have heard like trying to get away from dependencies, right? Decouple your code. Composition is an excellent way to approach that. The only thing about that is that you have to write your software to be, you guys have heard solid, right? Single responsibility. Same thing. Your units should be only have one responsibility. But I do think this is a good example because you have multiple things down the one entity. It's the same thing. If you create a class and you have a bunch of dependencies, that's a bad thing. Each thing is its own component. So yeah, it's a good thing to learn, and Unity is an excellent way to approach it because you have a visual one. What's up, Kevin?
let's say I had a bullet and I wanted to hit the wall. Let's say it was, I don't know, a cannonball, something
Right.
big, and I wanted the impact to be so big that it also caused the block to deflect the other slate block to deflect.
Sure.
I think it's called splash damage.
Right.
How would you do that?
You could add force. So I'll show you in my, just to kind of follow the logic. One second. The script. My effects manager. So in this is a singleton manager. Every one of these, whenever something happens, some event happens, it goes to the effects manager and it says, hey, you know, an impact has happened or fire has happened. You can see on these events, on ammo fired, on ammo impact. So if you attached a method, say your explosion thing, part of the ammo fired data and the ammo impact data, you get like velocity. So you could say, well, I hit at this point, and the Raycast, by the way, they do return what you hit, the collider, at what force you hit it with, stuff like that, right? So if you, all you have to do is grab that rigid body and do an add force, or if you wanted to do an explosive force, they actually have a method for that, and boom. The wonderful thing about this approach is that none of this cares, right? Like what you do when you have an impact. It just says whatever's attached to my own impact, fire that. Right? So if you wanted to, I don't know, make the sun go out, you know, whenever something hit, you attach a thing that turns a method that turns the fire out. But yeah, you can add, in fact, I mean, I even have some of the examples for that. If you look at the, slow heavy ammo, if you pull this is a prefab, so this is an instance of it, but I have, is affected by gravity. Now I'm not using the rigid, the built-in gravity, but that's okay because I'm applying my own gravity, the -9. But that's then you could change that as you want, right? Like you wouldn't want to change gravity because that's going in the engine because that's going to affect everything in the game that uses gravity. But if you apply your own, then if you want gravity less or more or whatever, and so then in addition to that, I'm adding 8 units of force to the right, positive X, yeah, to the right, and you go there. But if you wanted to tack on anything and just assign it to that an ammo explosive force, add that on there and boom, you have boom. Yeah, I'm expressive with my hands.
No, we were talking about turning gravity off and not watching it float.
Hey, let's do it. Here.
So you shoot down and then it float up and hit your enemy.
Let's. All we have to do to make reverse gravity is change this from a negative to a positive. Let's do it. It's fun.
All things.
All right, our slow heavy ammo is slow and not so heavy anymore. Oops. Now it's slow and dead. I think that's a Unity crash right there. All right, thanks you guys. You killed my Unity.
That's funny. You just said
No, we're gonna be right back, folks, after this important message. Yeah, if you didn't know, Unity is kind of a beast, so it is kind of a beefy system to get going.
Yeah, I had to pull it off because I didn't have room on my computer anymore.
Yeah. I mean, just loading it up is
Yeah.
Kind of a monster, but it is powerful, super powerful
So if
tool.
he does it the second time, it crashes again.
Yeah, no way,
Open
man.
up an issue.
You're gonna crash again. This is perfect programming that was done over the course of 2 weeks and multiple Vegas trips. Right? All right, let's make sure our bullet is floatable. Slow heavy is positive. All right, let's do it. All right, let's watch our bullets flow.
Now that's me in a game.
Why does everything look like clouds? All right, cool. Any other questions? Anybody have any, how much development have you done? Made anything cool?
I've been on a video game development club and we made a small shooter game. But
Get
it
some
was-
game jams?
Yeah.
Orange County's a good place. They have some good game jams out there. Anybody else have any questions? What's up?
How does the force get transferred between colliding objects? Is there a force property on one of the objects and that gets...
No. So anything in the game engine, period, that you want to apply physics to, force or otherwise, it has to have a rigid body. And rigid body is literally just the ability to do physics on it. So, perfect example, the thing that I was just making, it has a rigid body on it. That's the only way that I was able to apply that upward force or the right force on it. So it doesn't, an entity doesn't just have the ability to do physics. But that's a good thing. Back to that composition thing. Not everything is constantly hitting the physics engine, right? Unless it has a rigid body on it.
And that's different from a collider.
Right. Collider is, in fact, you can totally have, and you most often do have the boxes. The boxes have no rigid body. You cannot apply any force. Well, I mean, if you threw one on there, but yeah, just a collision of, just a determination, is this item inside of this other item? And then we have some kind of force to push off of it. Yeah. Different. But they work together, right? Like, I mean, in order to apply physics to something, meaning something else can, say, push off of me, you have to have a rigid body on it. So a collider, without it, you're gonna, run into issues. But sometimes you want to use colliders for not necessarily physics, right? Like, I just want to know when I move something over, did it run into this? Not necessarily push anything off of it. I just want to detect on collision enter or on collision exit or something along those lines. They're useful for a lot of stuff. And again, they are very fast, right? Like most things that you use, I'll give you an example of usefulness of it. Fighting games, right? Like Street Fighter. So you would never try to map out every move. When you do a fighter, especially a 2D fighter, every move that you have is a new sprite. Like his leg is here, and then it's here, and then it's here, his arm's here, right? You would never try to map out every divot of their arm on that computationally insane, right? What you do instead is you have what's called a hitbox. And that hitbox is essentially a square around this, very cheap, but when that square, that's why, like, if you ever notice older fighting games, you get this close to someone's face, you got hit. You're like, wait a minute, I saw like a millimeter between the two, I didn't punch him, whatever. Well, that's the hitbox registering a hit, and it's a good idea. I mean, I will say they've gotten pretty good about. There's some techniques that will blow your mind on, like, taking colliders down. You'll do this in this stuff too, is like if you're not using a collider, if it's not close to some other grid, I don't even want the engine to see it. I'll turn that off, right? Like if you think about if you're doing a RTS, well, if these guys are on the other side of the map, why would I want them to even be registering that? I don't want them to calculate whether the box is in here or what. No, I'll set up a grid system. If you're not within this grid section, I don't even touch you. It's again, optimization techniques, right? It's good stuff. But I do like seeing, you can see a collider on my, that's why I was able to push this over. I have a tiny little collider. By the way, you have to be careful. When I first made this, I put a box collider on this thing. This box collider was sticking out past the end of my gun. So when I first started hitting my bullets, well, the interesting thing about it is because it was the bullet was adding just a little bit of force, but in mass, it was pushing my guy forward. And I'm like, what's going on? Why is this moving forward when I'm shooting? Sure enough, it was running into my box collider. You got to be careful with that, but it is something to think about, especially when you start making them. You make a tank. You don't just want to throw a mesh collider on there, because every triangle of that entire thing is getting checked, right? Like it's essentially shooting one of those rays out for every poly on that mesh to see, have I hit something? Now, there are times to use those mesh colliders, like if you want super, super accurate, again, the face thing, right? Like if you wanted to, you were doing a VR thing and your fist, this knuckle, catches this side of his face, you want that to register as a punch, but not here. Maybe it's worth the use, right? You can do it, but it's all about design. 9 times out of 10, putting like 20 box colliders on something, way cheaper. Again, think about it. How many polys are on even a low poly thing? You've got hundreds, right? Like hundreds and each one of those calculations, as opposed to 10 box colliders or 15 box colliders, still way better. Yeah, that's usually the approach. Anyway, that's pretty much the talk. Any other questions? Andy? What's up, Kevin?
This is a question because I've seen when I play games, like I never see the edge of the map, so to speak, like this.
Oh, yeah.
Is there a way to put ambience into the map?
Absolutely is. Usually it's referred to as occlusion. So if you move your occlusion down, you're basically like anything that's outside of a certain area, I don't render that, right? So it actually, truth be told, it actually happens all the time. There's a wall over here, right? But you guys don't see that, and so the game says, hey, if this isn't in the function of my camera, don't render that, and that saves a lot. I will say, you get into game development, you're gonna spoil yourself a little bit because you're gonna see things in games, and it's gonna make you angry because you're gonna know how it works, because games are all about cheating, right? Like because you have to do it for optimization reasons and whatever. But yeah, it's all about cheating. All this stuff on the outside. This right here, this giant floor, that's just a giant box. Literally just a giant box with a texture on it. It's cheating, right? Like I don't even go to the expense of doing the sky. So if you the sky back here, that's all just the. I have it turned off, but it's all just one giant thing that's the wrap, so that anywhere your camera looks at, you're seeing that sky. It's all fake, I'm telling you. But and you pull back that curtain, you're gonna see stuff. You're just like, come on, like this is but yeah, you'll ruin yourself a little bit. Yeah, but it's fun. I will say, and I know there's a ton of web devs in here. And by the way, I'm not a gamer. Madden maybe some little bit, whatever. This is the most rewarding software development I've ever done. Like when you build something in here, the feedback that you get. This is a terrible game, right? Like after I build stuff, it's fun to just shoot, right? Like the spell thing. Like I'm sitting there trying to get some work done. Oh no, what? I got this effect working? Oh, this is fun. Yeah, this is cool. I'm shooting out in the air. What? That visual feedback is really good. And if you'll allow me to go on, the wonderful thing about doing it in Unity is that you learn CSharp, which can totally roll into any .NET development, which also can roll in any Blazor development, which is the next thing coming, and all of you young devs should absolutely get into that. But I digress. Any other questions? Anybody want to know anything? Questions about game dev, getting into any of this stuff?
Sidetracking one.
Do it.
So if you don't want to answer it, someone else has something better to ask, go for them. So,
there you go.
If you could create a game development sort of platform and whatnot, but it's using functional programming as a paradigm as opposed to object-oriented paradigm, what would be the issues you've come across?
I'm not going to say you can't do it. I mean, so Unity, just as an example, you absolutely have performance increase by going with functional.
Yeah.
Unity has actually implemented recently something called the ECS, which is the entity framework, which is exactly that, to where you build your stuff with structs, and that way you can, all your arrays are in line, everything. It does all of its system right now. I'm not using ECS on this at all, but if you want to render something, it just basically goes and looks for it each time, which is slow, as opposed to simply having a, hey, this is process all my rendering stuff, then process all this, which as an array is very fast. So I would actually say if you wanted to get into something like that, you'd be ahead of the game and where everything else is going. It wouldn't be a bad thing. I actually can't wait to see like a Go engine, to see, you know, what that's capable of. But Unity's doing a real good job. Again, this is like a transpiled thing, right? Unity's written in C++ because you don't write game engines are rough, right? Like, I mean, you talk about software that needs to be really fast. Game engines are one of the big ones. I mean, you're talking about real-time rendering. It's not even like a Blender thing, right? Like real-time rendering. That's why it's such a beast. It's got a lot of tools and everything stuff. Yeah, I would be quite interested to see someone come up with something, but I just say like architecting it be difficult, right? Like the trade-off, even just in a language in general, functional stuff is harder to do as opposed to OO, which is kind of the, well, I just created there's a reason OO, I mean, because you got to remember, C and everything else that came before, they went to OO because dev cycles were so much faster. It's easier to think in objects than it is to do, it totally is, man.
Not to disagree with you on that one.
No, maybe for you, but for the math, I mean, again.
I would say it's because you've been trained in OO already. That
No. I didn't start in OO, but I will say that coming from OO, it's hard to go to functional stuff.
Definitely.
Well, so barrier of entry for something like that is more difficult. Getting most people in that mindset. That's why I say dev cycles are faster. It's because you can get more people to do it the easier way than you can, you know, I mean, rest and all that stuff. But I would love to see it. Again, that's where this is going. I mean, you can't deny the optimization techniques of it. That's where this is going. That job system with threading and everything, that's where it's got to kind of be if you want 100,000 units on your screen doing stuff. You can't do that with this, right? Like I could probably even, I mean, this is a fairly beefy laptop. I could probably clear 5K objects doing various things at any given time, right? Without my frame rate going to absolute crap. You want to process 10,000, 100,000 units doing anything, moving an inch. Yeah, you're gonna have to switch, but and get into some threading and stuff. But again, Unity's doing a pretty good job. That ECS stuff that I've seen, man, you look at some of the demos. But I remember before ECS was ever even like out in beta or anything, the guy that was putting it forth had a demo, and it was a simple castle raider, but he had 100,000 units shooting arrows and stuff at each other at a screen. There's a game, I think it's called a zombie game, We Are Billions or something. Man, just thinking about, if you have no rendering, no colliders, no nothing, literally just here's a unit, I want it to move and do anything, and you do that by 10,000 or 20,000. I don't know how they do it. That's some really impressive stuff, but ECS and jobs will get it done for you. Yeah, you should do that. You should write you an engine in something that doesn't suck. Go or maybe
like
Rust or something. Yeah, it'd be cool to see. F# maybe? Nah. I love .NET, but F#, just Go and stuff is gonna blow it away. So yeah, we got to be realistic, right? Anything else? Anybody? You, man. You wouldn't hear me start over there in the corner. Anybody else? All right, cool. Colliders. There you go. Everybody.